More definitions. We will say that an infinite sequence is bounded above or bounded below, provided that no matter what lowercase n is, that this term right here is no bigger than some number, okay, say big M. Can't be true sometimes, got to be true for all values of lowercase n. Likewise, this has to be true for all lowercase n, if indeed the sequence is bounded below. And quick example. One we took a peek at a few moments ago. Uh-oh, I lost my board. Hold on. Shoot. Got it back. Now, it is the case that this is a strictly increasing sequence. And so notice that if it's strictly increasing, it's going to be bounded below by whatever I get when n is equal to 1. That's just going to be 1/2. Now, as far as being bounded above, since I'm strictly increasing, as long as the limit as n increase that bound is equal to some finite fixed real number, that'll be an upper bound. And that being the case, if I take a peek at the limit, as n increases without bound. Okay, I don't know how to value this limit. So maybe look at it this way. No calculus. If your places n with an x here and here, set y equal to it, you got a rational function. You studied this so darn well back in pre-calculus. And you know you're going to have a horizontal asymptote at y equals some constant because the degrees of the polynomial upstairs and downstairs are the same. And that constant is just a ratio of leading coefficients, so that'll be 1 to 1, which means you get just leave this. If you want to use some tools of calculus to get the same answer, I could come in. Notice I didn't change anything yet. But if I multiply by this funky looking form of 1, then notice that gives me this. Now, as I increase that bound, that second term goes to 0. That's going to leave me with a 1/1, because that's just simply equal to 1. Sorry if I'm running out of room. So second way of looking at it. Or how about this? A third way. Use L'Hopital's rule. Oh, but I can't. That's a discrete variable. So let me make a switch. Here's one application of L'Hopital's rule. And with a bit of cancellation. The limit of that constant as x does anything that Darwin pleases is just that constant. So through a string of transitivity with equality as a relation, certainly a valuable limit a third way, whichever way you prefer.